In the previous video, we did our first example of a trigonometric integral. We integrated sine x raised to the third power. And this is going to be a special case of a more general type of integral that we'll want to do here in this section. So it's going to be integrals that look like this. Sine x raised to the nth power, cosine x raised to the nth power. And so in the previous case, we had m was 3 and n was 0. Cosine x raised to the 0th power is just 1. And so as it turns out, there's two major cases to this. There's the case where at least one of m and n is odd. And then the other case is going to be when both m and n are even. So this is, if at least one of them is odd, this is going to be the easy case for us to do. And so we're going to work through an example of that here in this section. It's going to be very similar to what we did in the previous video, just a little bit generalized. So let's say that we are in this nice case, that at least one of m and n is odd. So here's the outline for how to do it. Pick the one. What I mean by that is either sine x or cosine x with odd exponent. If they both are odd, we have sine to the 5th x times cosine cubed x. You can pick either one. That's a nice situation. So pick the one odd exponent and split off one copy. So for example, what I mean by that is we could say sine to the 7th of x is sine to the 6x times sine x. We're going to split off one copy of sine x. Then we're going to use the identity that we were looking at before. So remember from this page, I said this was going to be the identity we'd use all the time. So use cosine squared x plus sine squared x is equal to 1 to rewrite the part that looks like that. So split off one copy, that leaves an sine or cosine raised to an even power. Rewrite this right here. And then we'd expand out the multiplication. And then integrate. And we would probably want to use substitution. So let's see an example of this. If this doesn't make sense, I think that working through one example will shine a lot of light here. So let's say that I ask you to evaluate, let's say, sine to the 5th x times cosine to the 4th x dx. So this falls into our previous pattern where we have, so here m is 5, n is 4, and at least one of m and n is odd. So m is odd here. So we're going to pick the one with odd exponent and split off one copy of it. So we're going to say that rewrite sine of x to the 5th is going to be sine x times sine x to the 4th. And sine x to the 4th, I'm going to write that as sine squared x squared. And so the reason I'm choosing to do this is that this will be tailor-made for us to use the sine squared x plus cosine squared x is equal to 1 identity, that we're going to replace sine squared x with 1 minus cosine squared x. Okay, so now, first step was we split off one copy, and then we used this identity to rewrite that term here. And so now our next step is to expand out the multiplication and integrate, and we'll have to use substitution when we integrate. So what happens here, we are going to expand this out as 1 minus 2 cosine squared x plus cosine to the 4th x times cosine to the 4th x dx. And I'm going to multiply through by that cosine to the 4th of x, so sine x times cosine to the 4th x minus 2 cosine squared times cosine to the 4th is cosine to the 6x plus cosine to the 4th times cosine to the 4th is cosine to the 8th x. And now we can see the point of what we've been doing here. So I think it's worth it for me to explain what's going on. If this didn't make sense to you, I think here's the payoff here, is that now we can use substitution. We can say that u is equal to cosine x, and then du is going to be minus sine x dx. So back here, if I were to say to you at this step that you need to use substitution, it's not clear what, how we can use substitution. We say u is equal to sine x. Well, we've got a factor cosine x, but when we have 3 factors of cosine x, we don't know what to do with. If I were to say u is cosine x, well, that's u to the 4th, and we've got a factor sine x to play along in our du. But it's not clear what to do with the other 4 factors of sine x. So what we did is that we split off 1 factor of sine x, knowing that that would be part of our du, and we rewrote everything else so that it could be in terms of cosine x. So now, at this stage, we can just say u is cosine x. We don't have any other factors of sine x to substitute in for, and life is good. So what do we end up with here? We end up with, here is minus du, so minus sign out in front, and then we just end up with, this is u to the 4th minus 2u to the 6th plus u to the 8th du. And so now to actually evaluate this integral, so minus sine u to the 4th becomes u to the 5th divided by 5. There's another minus sign, so plus 2/7 u to the 7, and then minus u to the 9th over 9 plus c. And then our final step is that we want to put everything in terms of cosine x. So our first answer didn't have u's in it. So now we want to go back in terms of x's. Okay, so this is a very typical procedure. So this will work. We can do this whenever we're in the case of sine m to the x, sine x to the m, cosine x to the n, where at least one of those exponents is odd. And I think this is a good place for our first pre-class problem. I want you to evaluate this integral here, the integral of cosine squared x times sine x to the 5th. So you should be able to do this using similar techniques.